Today we are going to do a video over the maximum and minimum values, how they are used in calculus and why they are important. So these are going to be some definitions that you need to know. The first definition is, suppose that C is a number in the domain D of a function f. Now, just letting you know that D can also be I for interval. Either one works. First, we say that f of c is an absolute maximum value of f on D if f of c is greater than or equal to f of x for all x in D. Second, we say f of c is an absolute minimum value of f on D if f of c is less than or equal to f of x for all x in D. 3, we say that f of c is a local maximum value of f if f of c is greater than f of x when x is near c. And finally, we say that f of c is a local minimum value of f if f of c is less than or equal to f of x when x is near c. And so that's the first definition that we need to know. And then just to note that the max and the min values of a function on an interval are called extreme values, or they can be called the extrema of the function on an interval. So the next definition that we need to know is a number c is to be a critical number for a function f if f prime c, so the derivative, is equal to 0, if f prime c is undefined. And the last one is the point c is an end point on D. And this may not make sense at the moment, but when we do some examples, it'll start to make more sense and be clear. So how do we find these? Did somebody say another 3-step process? Because that's how we're going to do it. So first we're going to find all the critical numbers. So sketching a number line can be helpful. So let me just put that should be a number line. 2, we're going to evaluate at every critical number an endpoint. And again, I'm going to show you how we're going to do that in the next few examples. And then 3, the greatest function value is the absolute max and the least is the absolute min. So these 3 steps are going to be able to help us find our max and min values that we need. All right, so our first example, we have, let's find the max and min values of f of x equals x squared minus x minus 3 on the interval of 0 to 2. So if you can remember, the first thing we're going to do is find our critical numbers, and how we're going to do that is we are going to find the derivative of f of x. So the derivative of f of x is going to be equal. Remember, you're taking your 2 and pulling it out to the front and minus 1. So that would be 2x. X on its own, the derivative of that is always going to be 1. And then 3, any constant, is always going to be 0. So now we're going to set this equal to 0 so we can find our x values. And we are going to get x is equal to 1/2. So that is going to be one of our critical numbers, and that is going to be our only critical number for this example. So number 2, we're going to make a number line. So we have our 0, which is going to be on one endpoint, and 2 is going to be on the other endpoint. And then we have 1/2, which we can say is roughly there. So now what we're going to do is we're going to take these numbers and we're going to actually plug them back into our original equation. So f of 0, I will show you f of 0. We're just plugging in 0 squared minus 0 minus 3 we get negative 3. And then for these, I'll just give the number. Feel free to use my hand if you want, but it's going to be negative 13 over 4. And then f of 2 is going to be equal to negative 1. So for step 3, what we can do is now figure out which ones are local max, local min, or absolute max and absolute min. So our local max is going to be at x equals 0, or what we can say is 0 comma negative 3. And then our local and absolute max is at, if you can see, is going to be that negative 1. So it'll be 2, negative 1. And then our local and absolute min is going to be at that negative 13 over 4. So it is 1/2 negative 13 over 4. So as you can see, we followed that 3-step process, and that's what we're going to do in the next few examples. So for example 2, we're going to find the max and min of f of x equal to x squared minus x4. So step 1. So as you can see, there is no domain that is given, so we are actually going to need to find those values. And don't worry, it is okay. It is a lot simpler than you think. We just need to do the derivative again. So the derivative of f of x is going to be equal to 2x minus 4x to the third. And again, we're going to set that to 0. And then what we can do is get 0 equal to 2x. 1 minus 2x squared. We take 2x equal to 0, and that's going to be x equal to 0 for one of our values. And then we have 1 minus 2x squared equal to 0, and that is going to get us x equal to plus or minus 1 over the square root of 2. So those are going to be our 3 critical points. So for step 2, we are going to make our number line. So we have negative 1 over square root 2. We have 0, and then we have 1 over the square root of 2. And if you remember, what we're going to do is we are going to plug that into our original equation. And feel free to pull out a calculator to do this, or do it by hand, either way. We're going to get 1 over 4, and then f of 0 is going to be equal to 0. F of 1 over 1/2 is going to also equal 1/4. So now that we found our critical numbers, now that we have what those numbers equal to and we plug them back in, now we're able to say which ones are our max and which ones are our min. So we have a local min at 0, 0. And then we have a local and absolute max at negative 1 square root 2 comma 1/4 and 1 over square root 2 comma 1/4. So as you can see, we're able to have 2 local and absolute max because we got 1/4 for each of those values. So for example 3, so find the absolute extrema of f of x equals sine of x minus cosine x on 0 to pi. So remember, what's the first thing we are going to do? We are going to find the derivative of f of x. That is going to be cosine x minus negative sine x. So that's just going to equal cosine x plus sine x. Now, we're going to set that equal to 0 to find our critical points. So what we get is sine x equal to negative cosine x, or if you have your trigonometry notes with you, you would know that tan x equals negative 1. So the only solution on 0 to pi is, so the only solution for that is if we take tan some number equal to 1 would be 3 pi over 4. Now, what we can do is make our number line. So we already know our two endpoints, which is going to be 0 and which is going to be pi. And now we know our critical point, which is going to be 3 pi over 4. So all we have to do is remember, plug that into our original equation. So f of 0 is going to equal negative 1. F of 3 pi over 4 is going to give us the square root 2. And then f of pi is going to give us 1. So now we can say what our absolute max and absolute min is. So our absolute max is at 3 pi over 4 square root 2 because that's greater than 1. And then our absolute min is going to be that negative 1. So we'll say 0, negative 1. So for example 4, find the absolute min and max of f of x equal to 2x plus 5 divided by x squared minus 4 on the interval of negative 5 to negative 3. So the first thing that we're going to have to do is get the derivative. Do you remember what we're going to use for this? We are going to use the quotient rule. Now, we have 2x plus 5 over x squared minus 4. So that is going to be equal to x squared minus 4 times 2 minus 2x plus 5 times 2x all over x squared minus 4 squared. And if you need help remembering that formula, feel free to go back and look at our derivative video, which will show you what the quotient rule is. So now we're going to head and simplify this. So 2 multiplied by x squared plus 5x plus 4 all over x squared minus 4 squared. We are going to set that equal to 0. So again, negative 2, and then we can take this and split it into x plus 1 times x plus 4 all over x squared minus 4 squared. And then what we're going to do is, since we're dealing with fractions equal to 0, if we were to multiply, so when we're dealing with fractions and it's set equal to 0, we're actually just going to get rid of the bottom, because if we multiply both sides by the bottom, it's just going to give us 0 equal negative 2x plus 1 x plus 4. And then it'll be 0 equals to x plus 1, and then x plus 4 if you were to multiply, or you were to divide negative 2 to both sides. 0 divided by negative 2 is just going to stay 0. So then we get 0 equal x plus 1, which is just x equal to negative 1, and we get 0 equal to x plus 4, which is going to be x equal to negative 4. And so those are two critical values. However, if you notice something, x equals negative 1 is actually out of the given domain. And so we're only going to be using the critical value of negative 4. So now let's go ahead and number 2, let's make our line. So again, we have -5 is one endpoint and -3 is the other endpoint. And then our critical value, which is going to be -4. So again, we're going to plug 5 into our original equation. And we are going to get -5/21. Plug -4 into our original equation. And we get -1/4. Finally, plug -3 into our original equation, and we get -1/5. Now that we have those values, we can show that the absolute max is going to be at -3, -1/5, and then our absolute min is going to be at -4, -1/4. So this is for example 5. Find the absolute max and min of f of x equals to 4 times x to the third minus 8 times x to the second plus 1. And on the closed interval, -1 to 1. I think we're missing a comma there. There we go. All right. So the first thing we're going to do, remember, is find the derivative of the function, which is going to be 12x squared minus 16x. We can go ahead and pull a 4x out, which will multiply by 3x to the -4. And now we're going to set that equation to 0. And what we get is 0 equals 4x, which x is just going to equal 0, and 0 equals 3x minus 4, which x is going to be equal to 4/3. Now, remember that our interval is between -1 and 1. So we can only use x equal to 0. The other one is outside of our interval. So let's go ahead and make our number line. We have -1 and 1, and then we have 0. Go ahead and plug those points back into our original equation. So f of -1 is going to be equal to -11. F of 0 is going to be equal to 1. And then f of 1 is going to be equal to -3. Now, we have our values. We can go ahead and get our absolute max, which is going to be at 0, 1, and our absolute min, which is going to be at that -11, so -1, -11. And that is going to be the end of our examples for maximum and minimum values in calculus.